This is the first of several videos that we're going to be doing on the topic of matrices. And so to begin with, we're going to look at some general properties of how to work with matrices, and then we'll get into more specifically how to work with them in both MATLAB and in Excel. So before we even start with that, we might think of why we want to do this. We use matrices in a lot of different engineering applications. We've already done this with MATLAB. We realized that in some of those problems we did, we were storing 10,000, 100,000 different values within a single definition of a variable. We'll also solve systems of linear simultaneous equations, which are, again, something that comes in handy in a lot of different applications. And in particular, like in mechanics of materials, you'll learn how you can transform quantities such as stress and strain from one coordinate system to the other. So that's just a few of the examples, but matrix math is used in a lot of applications. So a couple of operations are going to be important that we're going to learn. But before we do that, just our general definition is that a matrix is a one- or two-dimensional array of values. We usually will designate that by a boldface type. And if we have the elements of that, we show them within the square brackets. Again, this is stuff that we've already gone over when we've done this in MATLAB. Size of a matrix, defined by the number of rows and the number of columns. So matrix A in this case has 3 rows and 3 columns, so it's 3 by 3. And matrix B, 2 rows, 4 columns, so it's a 2 by 4. When we write about an element of a matrix, we usually show that as lowercase, and the row number and column number are the subscripts. So the row number first, and then the column number. Now, of course, in MATLAB, we know that we use the same nomenclature, but with the row followed by the column, but we do that with these values in parentheses. So the matrix name followed by the row and column number in parentheses. So a few things we're going to go over: how to add matrices, multiply by a scalar, multiply two matrices together, find the transpose, and then in the next video we'll look at determinant and inverting matrices. So first of all, to add two matrices together, they have to be exactly the same size, and when we add them, we simply add those individual elements. So in this case, you can see the 1, 1 values of both those matrices are added together, the 1, 2 values, etc. So in this case, you can certainly change the order of the operations, and so we say it's commutative. To multiply a matrix by a scalar, again, that's an element by element multiplication. And so again, in this case, the scalar is k, and it just gets multiplied by every element within there. Now what we find sometimes is that it's useful to use this property when we're reporting a matrix that has a very large or very small numbers here. So in this case, this is obviously a mechanics of materials kind of things where you see a matrix here that involves things in the millions. So it's a shorthand way of writing this. If we show each one of those values multiplied by 10 to the 6th, then again, that matrix multiplication applies there, and so each one of the values is going to be multiplied by 1,000,000. When we multiply two matrices together, the important thing to remember is that you can't always do that. They have to have compatible sizes. And in this case, the first matrix A has to have the same number of columns as there are number of rows in B. And the matrix C will have the same number of rows as A and columns of B. So if we look at these, if we're going to multiply A cross B, we can say we've got a 2 by 3 multiplied by a 3 by 2. And yes, we can multiply those two together. The size will end up being a 2 by 2. Now here's an easy way to remember that. I'm multiplying a 2 by 3 by a 3 by 2, just write them next to each other like that. Those middle values have to match, otherwise matrix multiplication is not possible. If they do match, then the outer values are going to end up being the size of that product matrix. And to do that, you multiply each element of a row by the matrix of a column. And rather than spend time reading that, let's look at an example. So we already know we can multiply these two matrices together. It's a 2 by 3 times a 3 by 2, and the answer is going to be a 2 by 2. So element C11, you take the first row of A and multiply those terms by the terms of the first column of B. So in this case, it would be minus 4 times 3 plus 5 times 2 plus 0 times 0. That should say a 0, by the way, a little typo there, but the answer is still the same. The C11 term is going to be minus 2. For C12, it's first row of A times second column of B. So minus 2 times 4 plus 5 times negative 4, once again plus 0, is minus 28. And so on with 2-1, second row of A, first column of B. I'll skip over the math. You can check that if you'd like. And 2-2, second row of A, second column of B, and so there is our answer. And so in this case, again, I'll skip over some of the calculations, but this is a 3 by 3 times a 3 by 1, and so our answer is going to be a 3 by 1, in other words, another column matrix. And again, you can check the numbers if you'd like. The first one is going to be 3 times 10 plus 2 times 5 plus 6 times 12, or 30, plus 10 plus 12, or 52. And again, if you want to practice these, go ahead and pause this and see if you get the same answer. This, of course, will be a 3 by 3. And there's the answer. Now in this one, again, you're going to have a 3 by 3, but when you go through all the steps of doing this, you'll find out that you get the same as matrix A. So matrix B is called the identity matrix. It has 1s on the diagonals, 0 everywhere else. And so when you multiply a matrix by the identity matrix, if that multiplication is possible, you get that same matrix back. And you should remember this. You cannot switch the order of multiplication, with the exception of when you multiply a matrix by its inverse, but we'll get into that a little bit later on. Transpose, we've done that in MATLAB already. You just switch the rows and the columns, and if you show that with the superscript T, that's the transpose. And again, you just switch the first row became the first column, etc. And in MATLAB, we know we can use the prime symbol for that. So that's where we're going to leave it for right now. The next time we'll look at determinant and inverse of a matrix.